In this video, I want us to talk about electrostatics as the study of static electricity. We have two types of charges, a positive charge and a negative charge. Let's just go through the definitions first before we can take a look at how they actually look like. So we have a positive charge and a negative charge. A positive charge originates with the removal or shortage of electrons. That is how a positive charge comes about. If you remove electrons or there's a shortage of electrons, we have a positive charge. While a negative charge, on the other hand, originates with the addition or surplus of electrons. These are very precise definitions that you need to be able to recall. And we are going to use these very definitions to conceptualize the idea of a positive charge and a negative charge. What if we don't have any shortage of electrons and at the same time we don't have a surplus of electrons? That is where a neutral object comes in. When the number of electrons is equal to the number of protons, we have a neutral object. It is neither positively charged or negatively charged. You've talked about this in grade 8. In grade 8, we talk about protons and electrons. Same is true in grade 9. We do talk about protons and electrons. Let's start with the neutral atom. When can we say that an atom is neutral? And consequently, in a larger scale, when can we say that an object is neutral? When we have equal numbers of protons and electrons. These small circles that you see with the positive signs are what we call protons. And these small circles or dots with negative signs is what we call electrons. So in our neutral atom, you can tell that we have 1, 2 protons and 1, 2 electrons. These ones without a sign, those ones are neutrons. They don't really affect our charge. So we have 1, 2 protons and 1, 2 electrons. Equal number of protons and electrons. Now let's talk about a positively charged atom. So in a positively charged atom, take a look at this. We have 1, 2, 3 protons. And electrons, we only have 1, 2. Clearly, we have more protons than we do electrons, right? We have more positive charges than we do negative charges. As a consequence, this atom is going to be positively charged because we have more protons than we do electrons. This is how a positive charge comes about. And then in the last diagram, take a look at this. We have 1, 2 protons, and electrons we have 1, 2, 3, 4. We have an excess of 2 electrons. If we pair this proton with this electron and this proton with this electron, then we have 1 and 2 electrons with no pairs. In a case like this, we say that we have 2 electrons in excess, and we can actually calculate the charge of that atom if we know the number of electrons in excess. But we're going to touch on that later. This is another concept you should have covered in the previous grades. Like charges repel each other, and unlike charges attract each other. So let's go ahead and take a look. If you have 2 electrons, they're going to repel each other because they are like charges. And then if you have 2 protons, the same is true. They're going to repel each other because they are like charges. Electrons repel electrons and protons repel other protons. While on the other hand, unlike charges attract each other. As you can see in this case, we have an electron and a proton, and they are attracting each other. The electron is pulling the proton towards itself, and the proton is pulling the electron towards itself. Let's move to the following concept. We're saying that if we have an excess of electrons, the atom is going to be negatively charged. But what is the amount of charge? If we have 2 electrons, what will be the amount of charge? If we have 3 electrons, what will be the amount of charge? Let's talk about the principle of charge quantization. In talking about this principle, we are going to be able to calculate the charge of an atom if we know the electrons in excess. So what does it say? The charge of an object is an integer multiple of the elementary charge. Well, let's talk about this elementary charge. What do we mean by the elementary charge? What carries charge in an atom is electrons. Electrons, they carry a charge of minus 1.6 times 10 to the minus 19 coulombs, right? What am I saying? I'm saying that they carry a charge, or QE, the elementary charge is equals to minus 1.6 times 10 to the minus 19 coulombs. This coulomb is the unit of charge. We're going to talk about it in detail at a later stage. What this principle is saying is that the charge of any object is just the number of electrons in excess multiplied by the charge of an electron. So you can see clearly that with this equation, this principle of charge quantization, we can be able to calculate the charge of any object as long as we know the number of electrons in excess. And obviously, if we're given the charge of an object, we can be able to calculate the number of electrons in excess using this very formula. So there we go. That is the principle of charge quantization. Let's go ahead and take a look at how it looks like when dealing with calculations. So take a look at this example. So the principle of charge quantization. An object has an excess charge of minus 1.92 times 10 to the minus 17 coulombs. How many excess electrons does it have? So we are given the charge of the object, right? The charge of the object is said to be equals to minus 1.92 times 10 to the minus 17 coulombs. This is the charge of an object. And the question is saying how many excess electrons does it have? We're looking for the excess electrons. But we know fully well that the charge of an electron is equals to minus 1.6 times 10 to the minus 19 coulombs. So with this information, we should be able to find the number of electrons that are in excess in our object. How do we do that? Well, we know that the charge is equals to the number of electrons in excess multiplied by the charge of an electron. If we rearrange this, we're going to get the number of electrons in excess being equals to the charge divided by the charge of an electron, right? The charge of the object divided by the elementary charge. So in using this formula, we're going to have N being equals to the charge of our object, that is minus 1.92 times 10 to the minus 17 coulombs divided by the charge of an electron. The charge of an electron minus 1.6 times 10 to the minus 19. N is equals to 120. So we have 120 electrons in excess in this object. That is why we have a charge of minus 1.92 times 10 to the minus 17 coulombs. This is how you apply the principle of charge quantization. Let's take a look at the question that follows. So question 2, an object has a positive excess charge of 2.5 times 10 to the minus 18 coulombs. How many excess protons does it have? We're going to use the same equation, right? We will find the number of protons in excess by saying that the charge of the sphere divided by the charge of an electron. The charge of an electron is minus 1.6 times 10 to the minus 19. And that of a proton is plus 1.6 times 10 to the minus 19. So in this equation, we would have 2.5 times 10 to the minus 18. This object is positively charged, so it has an excess of protons or a deficient of electrons. So we're going to have 2.5 times 10 to the minus 18 divided by the charge of a proton, because it has protons in excess. The charge of a proton is 1.6 times 10 to the minus 19. Don't forget that of an electron is minus 1.6 times 10 to the minus 19, and that of a proton is plus 1.6 times 10 to the minus 19. This is about 96 protons. We need the number of protons or electrons to be a whole number. We cannot have a fraction because we cannot have an electron. So this object right here has an excess of 96 protons. The last question, an object has an excess of 200 electrons. What is the total excess charge on the object in coulombs? Well, we have the number of electrons. We are looking for the charge, but we do know the charge of an electron, the elementary charge. So how do we answer this question? Well, still the same principle, quantization of charge. We have Q being equals to N multiplied by the elementary charge. So what is N? N is the number of electrons in excess. In our case, 200. And the Q is the elementary charge of an electron. So we have minus 1.6 times 10 to the minus 19. This is equals to minus 3.2 times 10 to the minus 17 coulombs. So there we go. That will be the total excess charge of an object with an excess of 200 electrons. This is how you apply the principle of quantization of charge. I did say that we are going to talk about these columns in detail. So let's go ahead and take a look at that. So as you've seen, charge is measured in units called coulombs. We know that one electron has a charge of minus 1.6 times 10 to the minus 19 coulombs. So one coulomb of charge involves a lot of electrons. More than a billion, more than a trillion. Actually, more than a billion, right? To have one coulomb of charge, you need more than a billion of electrons. So you can agree with me that a coulomb of charge is a very large charge, right? If it requires a billion of electrons, well, way more than a billion of electrons. So in electrostatics, as a consequence, we often work with charge in micro coulombs, right? This is the sign for 1 micro coulomb, right? You will need to remember this. Usually in the examination, charges are given in terms of micro coulombs or nano coulombs. So 1 micro coulomb is equals to 1 times 10 to the minus 6, and then 1 nano coulomb is equals to 1 times 10 to the minus 9. So as soon as you see micro, just know that is times 10 to the minus 6. And then as soon as you see nano, just know that it is times 10 to the minus 9. We talked about the principle of charge quantization. Let's talk about the law of conservation of charge. So the algebraic sum of the charges remains constant in a closed system. The algebraic sum of the charges remains constant in a closed system. So this is the law of conservation of charge. So if we have two spheres, A and B, and you let these two spheres touch, right? You let them touch, and after that, you separate them. What will be the new charge on the spheres? When they touch, there is an exchange or there is sharing of electrons. If A has more electrons, it will give B some of its electrons, so that after they're separated, they have equal number of electrons. The same is true. If B has more electrons than A, then it will give A some of its electrons, so that after they're separated, they have equal number of electrons. So the formula we use for the law of conservation of charge, or if we want to find the charge on two spheres after we let them touch and separate them, we use Q nu. We use Q nu is equals to Q1 plus Q2 divided by 2. You just simply add the two charges and divide them by 2. The law of conservation of charge. Let's take a look at this example. Two identical insulated spheres have different charges. Sphere 1 has a charge of minus 9.6 times 10 to the minus 18 coulombs. And then sphere 2 has an excess of 70 electrons. If the two spheres are brought into contact and then separated, what charge will each have? Okay, so we are looking for Q nu. We know fully well that Q nu is equals to Q1 plus Q2 divided by 2. So we have sphere 1 and sphere 2, right? Sphere 1 has a charge of minus 9.6 times 10 to the minus 18 coulombs. So no problem there whatsoever. We can just go ahead and substitute that in place of Q1. Let's take a look at sphere 2. Sphere 2, we are not given the charge. We are given the number of electrons in excess. So we have to calculate the charge ourselves, right? Because we know that if we have the number of electrons in excess, we can calculate the charge using the principle of charge quantization. So let's go ahead and do that. For the charge, so the charge of sphere 2 will be equals to the number of electrons it has in excess multiplied by the charge of an electron. So how many electrons does it have in excess? It has 70 electrons. And the charge of an electron is minus 1.6 times 10 to the minus 19 coulombs. One electron carries a charge of minus 1.6 times 10 to the minus 19. So if a sphere has 70 electrons, you just multiply that by the charge of one electron. This is equals to minus 1.12 actually times 10 to the minus 17 coulombs. So you can see here we are using the law of conservation of charge and the principle of charge quantization at the same time. Okay, so we have Q1 and now we have Q2. We can go ahead and substitute in order to find the charge that each sphere will have after separation. So let me just drag this to the side. Let me put it somewhere there. Right. So Q1, the charge on the first sphere, that is minus 9.6 times 10 to the minus 18, plus the charge on the second sphere, we have minus 1.12 times 10 to the minus 17. Everything divided by 2. The new charge on each sphere will be minus 1.04 times 10 to the minus 17 coulombs. So this will be the new charge on each sphere. They are going to have the same charge.